Systemic primary carnitine deficiency is an inborn error of lipid metabolism. And as you can probably guess from the name, it's caused by a deficiency of carnitine. Carnitine is responsible for the transport of fatty acids into the mitochondrial matrix, where they can undergo beta oxidation and subsequent ketogenesis. Let's first break down the disease's name. The word systemic just means that it affects the whole body. That is, the disease is systemic. And the word primary in primary carnitine deficiency means that the carnitine deficiency is the main cause of the disease. In other words, the carnitine deficiency is not secondary to something else. It's the primary problem. Also, before we get started, make sure you review our scene on fatty acid breakdown and the carnitine shuttle, as this video builds on that one. Next, I want to briefly review the carnitine shuttle and beta oxidation. Beta oxidation is the process that breaks down fats and generates energy from them. The enzymes for beta oxidation are in the mitochondrial matrix, so the first step in fatty acid breakdown is to get fatty acids into the matrix. That's where the carnitine shuttle comes in. The carnitine shuttle is used to transport fatty acids into the mitochondrial matrix, after which they can undergo beta oxidation. Let's go through this more explicitly. First, fatty acids combined with coenzyme A to form fatty acyl-CoA. The fatty acid is then transferred to carnitine, forming fatty acyl-carnitine. After its attachment to carnitine, it can then pass through the inner mitochondrial membrane into the mitochondrial matrix. Once in the matrix, the fatty acid is transferred back to CoA. The resulting fatty acyl-CoA can then undergo beta oxidation, which generates energy. With that out of the way, let's get back to the story. This image takes place back at our meat chute. But what did the meat chute represent again? Oh, that's right. The meat chute represents the carnitine shuttle. The word carne means meat, like in the word carnivore. So the meat chute must therefore represent the carnitine shuttle, because it shuttles meat from one place to another, right? With that out of the way, let's take a closer look at the meat shuttle. Wait, it appears to be broken. Take a look at all of our contestants piling up before the trap door. They sure seem confused. Since the trap door is broken, there is no carnitine. That is, there's no meat. That's why carnitine deficiency is right there in the disease's name. If there is no carnitine, we have no way to move fatty acids into the mitochondrial matrix. Think back to our image on the carnitine shuttle. Where does the shuttle lead? That's right, the shuttle leads to the mitochondrial matrix, where our unlucky contestants will meet the beta oxidation oxhydra. Now remind me, what do the contestants have to do again? Oh yeah, that's right. They have to paint sour cream on an easel with nothing but a croquet stick. And if they mess up, down the carnitine shuttle they go. The sour cream represents fatty acids, because sour cream is both fatty and acidic, and the croquet represents CoA. When fatty acids and CoA combine, we are left with fatty acyl-CoA, which is represented by the phrase fatty easel croquet. Get it? Fatty easel croquet for fatty acyl-CoA. At this point, fatty acyl-CoA is normally transferred to carnitine, thereby forming fatty acyl-carnitine. Fortunately for our contestants, though, the trap door doesn't seem to be working. When carnitine is deficient, as symbolized by our broken trap door and lack of meat, we get a buildup of fatty acyl-CoA. This also leads to a buildup of fatty acids in general, all because we're unable to form fatty acyl-carnitine, right? See the big pile of sour cream for our contestants? This represents the fatty acid accumulation seen in patients with systemic primary carnitine deficiency. I don't think our contestants will be using much sour cream today, though. At least not while this meat shuttle is broken. Okay, now for the question we've all been wondering. Why is our meat shuttle broken? I thought we had people in charge of this. Oh, wait. Take a look at the lab coat wearing employees over there. It seems they've been slacking on the job. I see crushed cans of ketone beer. And wait, what is that? Let's call it sugar. Let these crushed ketone cans and sugar remind you of hypoketotic hypoglycemia, a common finding in systemic primary carnitine deficiency. This is high yield and is probably how you'll get tested on exam day. Between periods of eating, the body relies on stored energy in order to keep the body running. Initially, the body breaks down glycogen from the liver, which then distributes glucose to the rest of the body. Liver glycogen stores only lasts for a short period of time though, typically for around 24 hours. During prolonged periods of fasting, the body needs to break down fat for energy. The fat can then be broken down into acetyl-CoA via beta oxidation, after which the acetyl-CoA can be converted into ketone bodies for distribution to the rest of the body, or it can go straight into the Krebs cycle. In patients with systemic primary carnitine deficiency, however, prolonged periods of fasting are especially dangerous. When these patients need to switch from glycogen stores to fat stores, things go awry. They can't break down the fat, so they are unable to generate the ketone bodies they need. This is what is meant by hypoketotic hypoglycemia. They are hypoglycemic because they have run out of the liver glycogen, and they are hypoketotic because they can't form ketone bodies to compensate. While we're here, I also want to mention the treatment for systemic primary carnitine deficiency. As you probably guessed, the treatment is to avoid the breakdown of fatty acids. These patients have normal glycogen storage and breakdown, so they really only get problems when they need to rely on fatty acid breakdown. So long story short, just make sure that these patients don't fast for more than 24 hours. This disease presents very similarly to a related disease, MCAD deficiency, which stands for medium-chain acyl-CoA dehydrogenase deficiency. The difference in these two diseases comes down to which step in the fatty acid breakdown is taken out. In systemic primary carnitine deficiency, carnitine is missing. In MCAD, acyl-CoA dehydrogenase is missing. You probably won't be asked to differentiate between these two diseases on test day, but if you are, look for the presence of carnitines in question stems. For example, the question stem might mention the presence of intracellular fatty acylcarnitines on muscle biopsy. If carnitine is there, you likely have one of the acyl-CoA dehydrogenase disorders. If carnitine is not there, you are probably dealing with systemic primary carnitine deficiency, because carnitine is deficient in primary carnitine deficiency, right? Finally, take a look at the other employees passed out on the control panel. Man, these workers are so irresponsible. This worker should help you remember the finding of weakness and hypotonia that may be seen during prolonged fasting. That being said, these findings are pretty nonspecific. Patients may also present with signs and symptoms related to the hypoketotic hypoglycemia, such as seizures. For systemic primary carnitine deficiency, it's really more important to look at the time course of the disease than to look for the specific signs and symptoms. Again, the take-home here is that patients are symptomatic only after fasting for 24 hours. So keep an eye out for this in question stems. Alright, now that's it. Let's quickly recap. Systemic primary carnitine deficiency is characterized by a deficiency in carnitine, which is the compound responsible for the transport of fatty acids into the mitochondrial matrix. A lack of carnitine therefore leads to the buildup of fatty acids and fatty acyl-CoA, which can be toxic to cells. During periods of fasting, the body relies on hepatic glycogen stores for about the first 24 hours. After this, fat will be mobilized to the liver, where it will undergo beta oxidation and subsequent conversion into ketone bodies. In patients with systemic primary carnitine deficiency, however, the fat cannot be broken down, so ketone bodies cannot be formed. This leads to the finding of hypoketotic hypoglycemia, which is essentially just a hypoglycemic state that is not accompanied by ketogenesis. MCAD is a similar disease that hits a different step in the same pathway, so it may also present with hypoketotic hypoglycemia. And that sums up our image on systemic primary carnitine deficiency. Now let's get out of here before they fix that trap door.